Hello and welcome to this series of videos on how to perform retrospective image analysis using Google Earth imagery. In this case, we're going to focus on how to perform the automatic detection with deep learning that can really speed up the process. We're going to use ArcGIS, and the result is going to be the automatic detection of our individuals of interest. Here we have ArcGIS Pro. We have different layers. We have this layer with one satellite image, and we have already segmented the individuals. We will go to this tab of imagery and then select this label object for deep learning. We're gonna save into an existing layer. We need to select the layer, the raster layer that we are going to use for the detection. Then we need to label the different opponents, the different individuals that we are targeting. So we could use polygons, we could use different tools for leveling. I recommend using these bounding boxes. So we're gonna get close using this segmented area that we already had from previous steps. We're gonna draw these bounding boxes, and it's gonna be class 1. It calculates automatically the number of pixels, so you can check more or less if there's one that's too big or too small for some reason. So if you have the layer of the segmented individuals, this is very straightforward. It just defining a bounding box that only captures the individual and maximizes where is it found and minimizes the background area. If you need to edit, you can just click outside the bounding box and then just rerun again. So I'm gonna speed up a little bit this process because as you can see, it's a bit like manual, but there are different options where you can speed up this by importing a layer of bounding boxes that can be defined using the function minimum bounding boxes. So after level the objects, we're going to go to export training data, which is on the second tab, and we're going to define where we want to store our training data. We will create a folder that will contain all the labeled data. For example, I'm going to set name. Oh, well, I need to create the folder itself. Okay, so this is going to be the folder where the little tiles of the different individuals are. And I'm going to add this rotation 45 in order to create a little rotation that does data augmentation. So it creates a lot of different images from a single image by rotating it. So this takes a bit long, as you can see. Well, not that long. So I already speeded it up a little bit. So we can see that this has been done, and then we'll go again to this imagery tab and go to train a deep learning model. And for this, we are gonna select the data that we have exported recently and let the model train. That will take a bit of time. So again, I'm going to speed up the process here. So it's already taking a bit to load. So I'm going to just remind you that for doing this, we need a GPU-enabled computer. So here I'm selecting the folder that contains the tiles with the training data. And I'm going to create a folder where the model will be stored, all the information from the model. I'm going to set a maximum training time just in case. And there are different models that we can train. After several tries and trying it all, I have found that the best model for this kind of data was this model. So I'm already picking it. But you can try them all or just run. There's one option that allows you to automatically select which one is better. So the training has started, and what I like to do is take a look on how my computer is doing, because this will take a bit of time. So I'm opening the performance of the computer, so we can see. Let's go here. We can see the usage of the GPU and how the CPU is being used. It alternates a little bit between GPU and CPU. So you can take a look how this is doing. So what this is doing, it's just trying to find the best way to use our data to detect the individual. So it's splitting the data into training, test, and validation. So it goes and checks every time how this is going. For example, if you want to take a look at the data that it's using for this, we can get to the folder that we have created with the exported data. Here it is. And you will see that we have the images and the labels, which corresponds to the coordinates of where the different individuals are within the tiles that have been selected. If we take a look at the images, for example, sometimes I like to just take a look and see if the crop seems correct. You can see the rotation of different images. So this is the same image, just rotated 45 degrees. So we can have this data augmentation, creating artificial data in a way. So we allow the model to train a bit more to play a bit more with the same data, but the test data is set apart directly. So we can see the massive amount of images that we generated. I recommend having a huge data set to let the model know. Sometimes we can use pre-trained models as well. This is called transfer learning, and it might work good for this kind of when especially when we don't have much training data. Okay, so this has been completed, training has been completed, and we can see already some metrics here. It says how much did it take to complete the training process, and if we click here next, we see the results of this model. So we see the accuracy. You can find more information on the website of what this accuracy means. And we see some examples of the ground truth data and the automatic detected data. So we can see that some opportunities have been detected. Some others, like these small ones, have not been detected, but considering the resolution of this image, I think this is quite good. So this was just an example. After this, I would just train a bit more the model, try different ones and see which one works better. But just to give an example in this video. So also if we go to the folder, we can open this HTML that contains the metrics. It has the accuracy again, and we can see again there's little images with the ground truth and the prediction on the right. And we can take a look on what the function of loss. Also, if we open this other readme, we can find which model was it, how much long did it take, and again, the same information. There's more information on the webpage for the deep learning tools on ArcGIS Pro, which I hugely recommend to take a look if you want to work on this. Now, if we want to use the model to predict, we're gonna go to analysis, tools, and we're gonna look for this tool, detect objects using deep learning. There it is. And here as input, we're gonna use the raster image. And we're gonna look for the model that we have just trained. We'll select the model. In this case, I need to select the model itself. So it has to be, let's see, there it is. So this type of file would be the model that we need to import. So it detects automatically the kind of images and everything, and we can just hit run. And it failed for some reason. Oh yeah, sorry, I didn't select the proper layer. So we need to select the proper layer would be the raster layer of the satellite image. I selected the segmented layer. So we hit on run, and again, it might take a little bit, not as long as training the data set. But I'm going to show again the GPU and CPU usage so we can track a little bit the needs of the computer. So what this is going to result in is going to be the automatic detected individuals from the image. So in this step, we can use like a huge terrain that look similar to our training data, but we can predict outside of the training area. This is very useful, especially if we have lots of Opuntias that were not within the area that we know Opuntia was. So this is quite useful. So it takes a bit of time to get started, but then it just gets in and has this bar indicated how much has been completed. So this is quite useful. And hopefully we're going to find the individuals that were segmented and perhaps some others. So this is it. The result is already a layer within our portfolio. And we can see that the detections have been selected in this pinky kind of color. I don't like this appearance. We're going to change it. So I'm going to set the real data. It's going to be this green. This is the true observations. And I'm going to set the predicted values. We're going to add, so no color within, and maybe it could be this purple, or better maybe a reddish color. There it is, and maybe a bit bigger so we can see it clearly now. Nice. So here we are seeing in red the automatic detected Opuntias, and in green the true Opuntias that were found in this area. So as you can see, there's some Opuntias detected outside the training area. There might be some false positives. We will need to check on the ratios, but you can see that some of the reals were detected, and I'm quite surprised that there are a lot of patches that look very similar to my eye, but the model did detect that they are not Opuntia. So I'm quite happy with this result. Obviously, there are some others that we are not sure. We would need to double check, but this indeed looks like an Opuntia. This was outside the training area, so I did not check if there was Opuntia there, but it definitely looks like it. And the model has automatically found it. So with models that have a very high accuracy, this will be super useful. So we need to remember that this will depend a lot on our model accuracy, the training data, and this is it. But this can really speed up the process in finding automatic individuals. So that's all. Thanks for listening, and gonna leave you with the next video.